Good morning, everybody. I very recently joined Spark, so this is my first ever State of the Science Summit. So I'd heard an awful lot about it. I tried to come twice and failed. My former employer was USAID and was stretched with the budget at the time. But it's wonderful to be here and to see an entire room full of people working on methane. When I was at veterinary school, I can't actually remember methane being mentioned in a full 5 years. So to think that there's an entire room of experts is really awesome and a testament to how this community has been pulled together. So I think this concept of community and the network is very much something that Spark is building. Frank, you've sort of coined this idea of a community, and it's felt like that. It's been a pleasure meeting many of you over the last few days. My background is more in international development, looking at the lower and middle income countries and developing livestock sector in those. And the aim of this session is to take a wide global perspective on productivity improvements and animal health. I'm going to channel a slide that Hayden showed yesterday, which looked at the hotspots where high emissions are occurring around the globe. And to try and understand how we can target those. I think we also need to keep in mind that we have a tremendous diversity of production systems. We have some of the pictures that we've seen over the last few days, many of them these stellar performers, the Messis of the livestock world in the Canadian dairy sector, the Californian dairy sector and beef sector. But they're the superstars, but they're not perhaps the norm, the typical. And this session is going to be a little bit more about those animals. So just to frame ourselves, just to think about a one cow dairy in India. That's the mode, that's normal. Or maybe think about pastoral animals grazing across the Barana Plateau in Ethiopia. Or fat-tailed sheep waiting to be loaded on a boat to be shipped across to Saudi Arabia. There's a tremendous diversity of production systems that exist, and that's the strength of our livestock sector. I think we might also want to just keep in mind that 80% of emissions originate in lower and middle income countries, and that percentage is going to increase. We have a huge opportunity, if that is the hope for this session, that to recognize we have a huge opportunity, that it's estimated approximately 1/3, maybe more if we're ambitious, of emissions could be averted through improvements in productivity and animal health. We should also remember that 1 billion people rely on the livestock sector for their livelihoods. Most of those are smallholder farmers in lower and middle income countries. And then finally, that the building blocks that underpin productivity and animal health gains also provide the essential platform for direct mitigation actions. Many of the technologies and practices, the brilliant science, will rely on that platform to be able to move forward with the technologies and deploy and operationalize and make the emission reductions. So to help me shine a light on how we can accelerate productivity and animal health gains, I'm pleased to call upon 3 speakers. So let me start with our first speaker, Dr. Seyda Ozkan. Seyda is an independent consultant and co-lead of the Animal Health and Greenhouse Gas Emission Intensity Network of the Global Research Alliance on Greenhouse Gases. Seyda, please.
Good morning, everyone. Thank you, Andrea, for the introduction, and thank you also, everyone, for being here, for making the time to join us in this morning. And I also want to thank the organizers for inviting me, for giving me the opportunity to talk about our work that we've been doing on the link between animal health and climate. So what I'm going to talk to you about today is a quantification framework and how we're representing animal health in quantification of greenhouse gas emissions. And this comes from a project called Animal Health as a Climate Solution, funded by Global Methane Hub, coordinated by Environmental Defense Fund, and implemented by various partners, including International Livestock Research Institute, Edinburgh Napier University, and others. So I just have the privilege to present you some of the results. And I want to thank, of course, my co-authors who have contributed greatly to the development of the framework. I want to give you a little bit of a background why we're focusing on animal health and climate. And animal health offers multiple opportunities across multiple system goals, from reducing greenhouse gas emissions to improving resilience, improving rural livelihoods, human health. And in terms of the reductions in greenhouse gas emissions, that could come from 3 different ways. The one that we have been mostly talking about is the emissions intensity route, obviously, and that's through improving production efficiency and averted losses in production. But also, it is possible to reduce absolute emissions through having fewer replacement animals and reducing the need for replacement animals. The last one is about avoided emissions, that refer to emissions that could have occurred but didn't because of an intervention. And we're also working on animal health because there's the policy context into it. So what we have seen so far with the publication of this FAO report, I've had the pleasure of leading the role of animal health in national climate commitments. We've realized that animal health has been largely missing as a mitigation option in climate policies and also in NDCs. And that comes from, or that has been due to mostly the limitations in quantification. So when we look at the state of quantification at the moment and why we needed a framework, we have seen this linear route that comes from the animal health condition that leads to production losses, and then that has a greenhouse gas impact, similar to when we have an animal health intervention that improves the production efficiency, and then we have reduced emissions intensity, which is not incorrect, but we have questioned this from other aspects. So far, the quantification approaches have been capturing a subset of impacts and modifying a subset of parameters, such as mortality, fertility, body weight, milk yield, and they have been also relying on simplified assumptions. Some of the methodologies that we have been using are also limited in terms of especially the methane conversion factor not being sensitive to animal health, or feed intake, digestion not being represented in relation to animal health. So there has not been explicit representation of the feedback mechanisms in this way of quantifying the emissions and how the effects propagate through the wider system level interactions. So we have now started seeing animal health not as an animal problem, but we've started seeing it as a system level challenge. So that has come through, obviously, the effects through the markets that influence policy influencing management decisions influencing productivity or product output. That has implications, obviously, on greenhouse gas emissions, both of the two having implications also for human health. So we wanted to develop a framework that makes the assumptions transparent and that considers trade-offs and co-benefits. So really, you'll probably read a lot about it when the paper is published. the transparency and explicit clarification of the assumptions is one of the two things that keep coming up in the paper as well. So the trade-offs are co-benefits really important for us to make decisions, not just for us as researchers, scientists, but also for policymakers to make decisions, and they want to know what the implications would be of their decisions. So what's in the framework is a systems-based approach. It's a structured map, not a model. And having said that, it's compatible with models and life cycle assessments. It does not prescribe any calculations, and it's more like a choose your own adventure depending on the purpose of the user, the objective of the user. They can choose different paths. That means users select relevant components, parameters, pathways based on their objective and decision context. So we have a list of parameters that users can consult in the paper, in the framework. They're not limited to them, but we have also offered them sources of data relevant to the components, parameters they select, and the parameters that also lead to subsequent parameters, so they can actually see what impacts they are chasing. So one of the pathways, I'm going to give you an example from one of the core pathways that we have. So here is the animal health intervention that has implications for animal health condition, that has implications on animal physiology. And by animal physiology, we're referring to feed intake, product output, reproduction of the animal that happens in the animal body, basically. So this is one of the core, this is part of one of the core pathways of the framework, but this is really the backbone, physiological backbone of many of the pathways. So when an animal health condition happens, we then see the management responses coming into play, but they might be affected by different factors, but in this pathway, this is management response related. So management decisions are affected, but they also affect what kind of interventions would be taken. So there's a link between the interventions and the management decisions. And the management decisions made based on several factors, they have an impact on the product output again, because the farmer may decide to feed the animal that is sick differently, or improve the nutrient quality of the feed, or it might choose different intervention options. And that might be for different reasons. Again, the role of the animal in the system may play a role here. And then the animal physiology, as a result, might have implications for the economics and markets because of the product output now produced as a result of the intervention and the greenhouse gas emissions and methane. This is management response pathway. And some of the other pathways have been influenced by sociocultural aspects. Like I said, the role of the animal plays a role here. Resource use, if we have the resources to actually produce the feed required, or the feed that now the farmer is going to choose. Policies and regulations will have an impact on the management decisions. Greenhouse gas emissions will have an impact on policies and regulations at the same time. And both the product output and the greenhouse gas emissions will have implications on the human health, and climate acting as a cross-scale influence. So we might have the same disease, but having different assumptions might actually, obviously, result in different results. Having an example for like a foot-and-mouth disease, for example, and the implication being reduced milk production, having a scenario A saying losses are absorbed, meaning herd sizes are unchanged, production losses accepted, no compensation is made elsewhere, the outcome would be lower product output, lower feed demand, lower emissions, as opposed to a scenario where losses are compensated, meaning herd expansion occurs, replacement production happens, production target maintained, and market compensation also happens, and the outcome being now supply maintained, additional feed demand happened, and emissions increase or may have been shifted. So lastly, what's in the framework is really about explicit integration of epidemiology and greenhouse gas emissions. It links animal, herd, and wider system levels. It makes the epidemiological management system boundary assumptions explicit and transparent, but it does so without the perfect methodology. So we can't wait for the perfect methodology to start working on on quantifying, and it supports the identification of trade-offs and co-benefits and also the iterative application. So we still need to improve the representation of feed intake, energy partitioning, and comorbidity, but we can do this in a modular way. And advanced understanding of behavioral, market, policy feedbacks, but framework doesn't really resolve these limitations. It just makes them explicit and places them within the wider system context. So we have a case study implementation using the FAO's GLEAM and have currently submitted a Global Research Alliance flagship proposal that uses the framework, combines it with the policy guidelines we're developing in specific country context. So we're aiming for a wider application of the framework and the policy guidelines. So with that in mind, I'm just going to hand it back over to Andrew. And if you have any questions, if your country is interested in joining the JRI flagship, you're welcome to reach out to me. Thank you.
Thank you very much, Seyda. And as a card-carrying member of the veterinary profession, we're very pleased to see this framework and to elevate the role that animal health can play in reducing emissions. Just a reminder, I have some questions prepared for our panelists, but it'd be far better if you were asking the questions. So please get busy and start asking questions and firing them in, and then we've got a nice bank of questions to work through. Our second speaker needs no introduction, or very little. Dr. Ermias Kebreab. He is the Associate Dean of the College of Agriculture and Environmental Sciences and the Director of the World Food Center here at this wonderful university, UC Davis. Ermias, please welcome to the stage.
Okay, good morning, everybody. I hope you had a good rest, and I'd like to thank everybody for coming to my birthday party yesterday. That was great. Okay, so today I'm going to talk about completely different things that I was talking about yesterday. Let's see. Move on. I'm not going to talk about health. I guess the other way. All right. Okay. Andrew just mentioned that one of the biggest challenges we have in terms of methane is about over 80% of the livestock-related emissions coming from low and middle-income countries, and we heard it from Aimable last year. Also, he gave us this nice picture, and then Hayden talked about how enteric methane emissions is one of the largest contributors. And around the world, we have over 500 million smallholder farmers that are keeping livestock, keep livestock for food security, excuse me, for food security and also for income and other things. So one of the missing things so far in low and middle income countries has been the ability to optimize the feed so that you can get better productivity. So we've had ration formation softwares that are available, but mostly they were geared towards the temperate animals, Holsteins and the like. So we don't have similar ones that are widely available for lower and middle income countries. So improving feed efficiency is one of the levers that we have in order to reduce the methane intensity. So if I quote Karen Boschman's and others' work, improving feed, excuse me, improving feeding and management is the most effective and widely applicable strategy for reducing methane emission intensity. And we took this to heart. And what I'm going to talk about mostly today is a global multi-institutional project that's supported by Global Methane Hub that's now is in its last year. And the way we looked at it is that we develop a digital solution that's available to farmers and extension agents around the world. And we do it in a sort of available in a mobile app format. So we tried to do it in a desktop format before. There's not really a lot of computers available to especially extension agents and farmers. So we went into the mobile app way. And what we did really was a lot of the investment went into developing the local feed libraries. Those are the things that are needed, because if you don't know what you have, what are the nutritional quality you have in the feed, then you cannot really optimize. So a lot of investment went into that, and also looking into what are the requirements of those animals as well. So a lot of research has been done. I was part of the NRC for dairy for the US, and it took us 7 years to collect all the data and put it all together into usable format. And so we need to do that the same thing for tropical animals as well. And then you put together the feed availability, the quality, and then the requirement, and then we have a way to optimize those diets. So the areas that we're working on right now, we have about 12 partner countries. We selected the ones that have a fairly high number of dairy cattle. So this project is focused on dairy. And of course, there's India there, and Joy McFadden from Cornell is leading the work in India. We're doing Southeast Asia, quite a lot of countries in Southeast Asia and in Africa. Coordinated in Cameroon, but also in Ethiopia, so the west part of Africa. And then recently we added Morocco and Bangladesh as well. And these are supported by institutions in the US, led by UC Davis, but also Michigan State and Cornell, and in Australia, CSIRO, and New Zealand, Massey University as well. So as I mentioned, a lot of the effort has been done to improve the availability, or to try to understand the local feed library. And the way we've done it is that work with our partners to collect those feeds that are sort of what's available in their area, and try to do a wet chemistry. But at the same time, we're doing the wet chemistry. We're working with Professor Daniel Uwizeye, who's here from Michigan State, to put together a database, and that database will help us. We try to make it open source so that people can utilize it, and also can upload their data into it as well. But we're also trying to come something a little bit different, which is we installed high resolution cameras in all of those different partner institutions, and every time they collect the data, they take a picture of that. And then through machine learning, we try to put those two together. And so that's at the end of, maybe in a few months or so, we can have a digital tool that will to allow you to take a picture of that ingredient, and then tells you, how much fiber or protein and things like that as well. So at least that's what Daniel tells me. So hopefully that will work. At the same time, we are also developing a NIR system, which is a near infrared spectroscopy system with ILRI, and that's a proven technology. So what we're trying to do is we calibrate those machines so that you don't have to do a wet chemistry all the time. You can use the NIR system to very quickly see what's the nutrient profile of the ingredient that you have. So the way we look at it is now we developed the feed library. So we have a really nice database that has been put together from all these countries. Now we already have a 2-year data that's already collected from dry season and wet season. And then moving on into in vivo trials. So already we've completed in vivo trials. We sent green feed machines to those countries. From Philippines and Vietnam, we've already completed the trials. Thailand and Indonesia are in the middle of doing those trials. We should be finishing by the end of the month. Ethiopia is about to start, and hopefully India will start very soon as well. So we have all these in vivo trials that we're going to be doing, and then we do field piloting. Once we have those trials, we go actually to the field, to the farmer's field, and make sure that the solution that we have, the mobile app, actually works as intended. If not, then we have to do some calibration as well. And then, of course, as new studies come up, then we can continuously update the system as well. So basically, we'll put together this requirement models for tropical animals, and then we have the NIR system to analyze the data. We have the using the mobile app to also take in the ingredients of the nutrient profile of those different ingredients, and then we put all that together into a mobile format. And then finally, what we would like to do in the next year or so is to use AI, work with companies like the Digital Green and ILRI, and put it into like a chatbot. So for a lot of people who are illiterate and they may not be able to sort of download and select diets and all that kind of stuff, you can basically use voice to say, I have a cow who is, I don't know, 300 kilogram and giving me 5 liters, and I have elephant grass and this available to me, and I wanted to increase my production from 5 liters to 6, 7, or 8 liters, and what should I feed? And then the system will take all this information, structure it, and put it into the AI, and run the model and bring the results, and then will respond to the user in the same language that the person is using for that chatbot. So that's what we're trying to work on. And then I just want to mention about the importance of using the circular bioeconomy, because one of the biggest issues in low and middle income countries is availability of feed. We need to have, how do you get more feed? And one of the ideas is that to use the crop residues and byproducts, and to increase the utilization of food waste for ruminants, and also better use of the manure as well. You can have smaller anaerobic digesters. Even if you have a few animals, you can still have anaerobic digesters to get some energy, as well as to use that manure for crops as well. So how do we transition this? How do we implement it? Well, as Aimable said the other day, we really need to have those livestock included in NDCs. When you have livestock in the nationally determined contributions, the states are really incentivized to do something about it, and then they can say, okay, if you do this, if you reduce emissions, then it can go into those NDCs as well. So that's one way in which we can try to get this moving. Financing is very important, so available credits for farmers to be able to utilize those kind of technologies, because sometimes there is a cost to incorporating some of the technologies that we're talking about. So financing is really a critical issue. And the third one is trying to scale up. Well, there's another project that we're working with called the Aim for Scale, and the idea is to really scale up some of the innovations. So we know a lot of those innovations work, but how do you really scale them up? And so the idea with this, which is supported by the Gates Foundation and the Presidential Court of United Arab Emirates, is really working with development banks or the World Bank and IFAD and others to help them to put together projects that have the potential to scale up. So finally, the takeaways are then ruminants in low and middle income countries are a source, but also we have the opportunity to use them as upcyclers and reduce emissions as well. And one of the ways to reduce emission is through precision nutrition and to optimize the diet so that the intensity of methane emissions will be reduced. And to that end, we are developing this technology, this tool, Ration Smart, that will include local feeds and then the requirement of the animals together to get a advisory of how much to feed the animals. And then finally, the circular economy, which is a big topic. We could have a full panel on it, but I just want to mention that this is really an important way in which we can have more feed available for animals. Thank you.
Thank you so much, Ermias. Lots of very cool stuff there to unpack. So our final speaker is Dr. Aimable Uwizeye. Aimable is a livestock policy officer with the Food and Agriculture Organization of the United Nations, where he leads the UN work on low-emission, climate-resilient livestock systems. Please help me welcome Aimable.
Good morning. Yeah, so It's a bit difficult for me to present after my first colleagues. I think they said almost everything. But as I'm a veteran of the summit, so I still have something to say. So I'm going to navigate through a case. I think, as Ermias said, we know that methane emissions are highly important in low and middle income countries. And of course, those systems, livestock, are highly affected by many things. Of course, there is a climate extremes, but animal health is very important. So why are we interested in animal health? Is because animal health is a non-regulated options. Any government will understand the need to invest in animal health. So here I'm going to give you a very quick case study on a study we are doing for Kenya, where we have modeled all options of mitigation across all livestock systems, especially ruminant systems in Kenya, looking at what would be the impact by 2050. This is very important because we are trying to convince the government to commit on methane reduction, because so far they commit on climate smart agriculture, but we don't know how to unpack the climate smart agriculture. So here is one example that I want to show. So we know that, I think this has been already said, that health animals provide opportunity to increase productivity. They can provide opportunity to reduce emissions. And of course, productivity gains means strong resilience and also high livelihood for farmers. We cannot implement any mitigation options if animals are sick. So that's why the basic is to ensure that animals are healthy. So this is very important because, of course, as Seyda mentioned, animal health conditions, disease will affect most of our activity data. And we try to understand how that effect will happen. And the best way, because of course we have kind of challenges in measuring such an impact, especially getting the data. So we use Monte Carlo to capture the whole distribution of potential impact of disease, and of course also the benefits, because Monte Carlo will go also up and down, of course, as you know. This help us to capture any effect of disease conditions. So one example here, we are looking at the intensive exotic dairy systems. Those mainly are the crossbreed of Holstein and local breeds in majority. We assumed a condition where, for example, the animal disease will affect 30% of the population. This will reduce, of course, certain of the key production parameters. And what we see is that the first victim will be the productivity. So in case of animal disease, the productivity will go down. Of course, that's farmers will lose their livelihood. And of course, if the animals are dying, they lose everything and they don't have any insurance and any recovery strategy when they lose animals. On the other hand, contrary to what people think, actually emission can go up, especially in the case of disease, because the digestibility of feed will be reduced. Therefore, the emission, actually, especially enteric emission, can be even higher in the case of the animal disease. So in this case, we're looking at actually two cases where even 20% of the dairy cows may die across the production cycle, but still the emissions are higher than the baseline if you compare it in this case. So why, and we look at, of course, what is the driver is mainly not the producing animals, but the not producing animals, in this case, the heifers, that their emission factor will go a bit higher. We compare also the distributions through this PDF to actually what happened. We will see that always the disease whatever the conditions, they will always lead to high emission intensities. And this is a problem, meaning that if there have been huge investment, of course, in animal health in low and middle income countries. But of course, we need to invest more. We need the capacity building for farmers to ensure that farmers are able to maximize the productivity of their animals. So to finalize, I want to finalize this on the good news. The good news is that we believe many of those countries are able to implement mitigation scenarios. And here is a case of the cleanup. What is behind this case is that we assume that all disease conditions, animal health intervention are well done. And here we can apply the cleanup. Of course, here we consider only that only 30% of farmers in Kenya will be able to adopt the cleanup if they have the opportunity to do so. And we can see that there is a high probability of reduction of emissions, more than 95% of likelihood, and can reduce up to 25%. As I was discussing with Ermias the other day, here we assumed the raw bound of cleanup effect 20%. So just to be transparent, that this is really the not maximum effect, because we assume that not the feeding conditions would be matching the current feed conditions that you see in the trials. So on that, I want to thank you for this opportunity. Happy for the discussion. Thank you.
May I invite our other speakers up to join us on the stage, please? Well, we are just getting situated. I like that to end on that note of optimism. I think we had some questions yesterday around this. And I think this whole area of improving animal productivity, animal health in emerging economies is a tremendous opportunity. We don't need to invent new things. We have the tools, we have the technologies, the techniques. That doesn't mean it's easy, but there's a huge potential for change and improvement. So let me go straight to our questions. So the first one here, and I think this probably lands mostly to you, Seyda, is there an opportunity to create carbon credits across the animal health sector as a climate solution space? Am I reading that right? Carbon markets, how can we tap into carbon markets by animal health improvements?
I think my answer to this would be not to get ahead of ourselves and ahead of the science. So currently our challenge is actually quantify and represent animal health conditions in quantifications credibly. Without doing that credibly, we might lose that credibility in that sense. So I think there is an opportunity. It might be immature to do it, like to start off with the carbon markets. So there is an opportunity to actually produce results-based finance or tap into results-based finance rather than creating carbon markets in the first place. And that could start with the national determined contributions we have just heard from Aimable. And so countries have the opportunity to actually quantify the impact of selected or some of the animal health conditions on greenhouse gas emissions, and publish them or as part of their targets, conditional on international support, international finance. So that could be one of the first ways that some of the countries can do, and most of the low to middle income countries.
Great, thank you. This next question, I think perhaps we'll start with Aimable, but perhaps all of you have an opinion on this. Lower and middle income countries face numerous barriers and issues: feed quality, genetics, manure handling, health, access to tech. There's a longer list, making it difficult to determine which problems to address first. Is there a hierarchy of priorities that should be followed? Does it vary by country?
I can start. I think what we see across different countries that not all countries, they have the same level of readiness. So meaning that the priorities will vary from a country to another. But of course, there are one key priorities if we are talking about animal health. For FAO perspective, animal health, especially transboundary animal disease, is very important. That's why FAO is starting the global partnership program on transboundary animal disease to address animal health across, which is a new way of partnership, because this will be country-driven and country-owned initiative. So on the other hand, we see that most countries have already existing veterinary services. Therefore, when you look at what we want to achieve in terms of productivity, emission reduction, there is what I see as a key priority is capacity building. Because we want to make sure that across the different solutions and different actors, they do understand what they need to do first. Because I may know what to do first, but doesn't matter my knowledge on this case. So we want to make sure that where the implementation is happening, that capacity is provided. Because there are countries that, for instance, we have supported in terms of capacity on emission, greenhouse gas accounting, policy, and so on. And of course, in return, they have committed to do something about methane. But at that time, it was that most countries just wanted adaptation, not mitigation. But that has changed. 48 countries that have been working with us, they have committed. So that means that when we make sure that the capacity is provided on the ground, that's really the entry point to better outline the key priorities for those countries, because they will vary, as I said.
Yeah, so maybe I'll talk a little bit about the aim for scale that I mentioned earlier. So what we're trying to do with that is come up with an investment blueprint and having a bundled approach. So it's not just about one intervention, but actually bundling those interventions. And that's exactly how projects, there are big projects with the World Bank and other development banks happening, is that we have to have all this priorities put together, but in a bundled way. So feed, for example, is going to be probably 60-70% of the cost. So a lot of times you include the feed availability and quality and optimization and all that. And then at the same time, you have to have health. But the health, it depends on the countries. In some countries, foot and mouth disease is a problem. In other countries, it would be mastitis, or you have issues with the young calves and things like that. So that needs to be part of that as well. They have management issues and water quality or access to water, heat stress issues, and also access to markets. You know, even if you produce more, if you don't have access to markets, then that could be a problem as well. So we are trying with this aim for scale, we're really trying to have a bundled approach. It's not just one intervention and one solution, but really a combination of solutions that is really tailor-made to the country, to the production system, to the livestock species that we'll be dealing with. So there's multiple factors that go into consideration.
Anything to add? Great question and great answers. Yeah, the stacking, bundling seems to be the way to go. Okay, wow, the coffee's kicking in, taxing my skills here. Where am I? It jumped. So how does the panel see animal reproductive efficiency factoring into this conversation? It seems like an area of massive opportunity that doesn't get talked about enough. Open cows have pretty ugly GHG footprints. Agreed. Who wants to take that one?
I think I'll start. I think this is also one of the areas where we need the package of interventions again, animal health and feed, for example, being together and bundled also with the genetic improvements perhaps. But when it comes to animal health, what I can tell you a little bit about is, so we're actually not only losing the animal that dies, we're also losing the animals that have not been born. So they are the unborn offsprings that are the reproductive capacity that has not been reached, or the productive capacity that hasn't been reached from that animal that dies, for example. So I think it's important to focus on multiple options, including animal health and feed together. And like Ermias said, take them into, as in the packages of intervention in that context.
Maybe I can add a small point is that, of course, we always engage farmers and the community in terms of reducing the production cycle. So, but it's a challenging one because most of those farmers may not be exposed to the markets, and they may see livestock through different functions, especially insurance functions, financial functions, and so on. Therefore, the sensitivity to the market and reducing the cycle is always challenging. But that's mainly happened with the multi-purpose or beef-oriented systems, while for the dairy systems, they tend really to understand the challenge because, of course, the wrong production cycle means inefficiency and they will lose money. So it's always depend on which system we are talking about. So we see much more progress with dairy as opposed to pastoral systems or other small scale that are not really oriented to the market.
Great, thank you. Next question. A number of studies have reported that heat stress increases methane production. I wonder if that is taken into account in estimating methane from lower middle income countries or in ration balancing. Ermias?
Yeah, so when we are doing the ration balancing, heat stress is one of the key parameters there that actually sort of that separates it from more of the temperate cattle and sort of the modeling that was done in temperate cattle. In tropical cattle, the heat aspect is very much part of it, and we try to do it in different ways. Heat stress has an impact on the animal in terms of reducing the dry matter intake, and it has an impact on, obviously, on the productivity once you have dry matter intake, but also even more than that, have reduced in intake as well, in the production as well. So yeah, when we do the calculations for methane emissions, that is taken into account, not only the reduction in intake, but also the yields. So per kilogram of intake, the heat stress has an impact as well.
Great, thank you. I'm going to try to smush a couple of questions together here. One is quite specific, Ermias. How many advisors are using the app you've developed, and how much emission reductions do you estimate have been reduced? Perhaps I won't tax your memory. I'll let you answer that one, and then I'll come with another one.
Okay, yeah. So the project is not finished yet. So we still have another year, or maybe a little bit less than a year to do that. So although the tool is ready, we have not launched it yet. But in the meantime, we are talking with several sort of interested parties. Particularly, we're talking with the World Bank and with IFAD, who are interested in using the tool. And the way it works is that you have to get it into those projects with the countries to be able to be used. So our approach right now is to try to work with countries and with development banks to put it into projects so that they can be used when those projects are launched. So yeah, we should be able to launch it and for anybody really to use by the end of the year. But right now, we are really positioning ourselves to make sure that those tools are going to be used once they are done.
Great, thank you. And just for our audience, you are blessed here with a wonderful agricultural extension system that links research to farmers and teaching. That, in my experience, is really unique. There are other strong systems in the developed world, but in the emerging economies, this is a huge gap. And farmers are being asked to do more and more technical things, change more and more rapidly, and really lack, in many, many countries, strong advisory services, whether that's public or private. And I am fascinated by the role that AI and digital technologies can help play to bridge that gap. The question that sort of links to this was, Ermias, again, even if the optimum feed is identified through your app, Can you speak to the obstacles farmers may face in acquiring the feed and some potential solutions to that?
Yeah, so the way the app works is really looking into what feed is available to the farmer. So the farmer will select the actual feed. We can do it either from voice, as I was saying earlier, but there's also a drop-down menu in terms of what feed is available in your region to be able to optimize. And so we're not asking farmers to come up with different feeds to feed their animals to improve their productivity, but from what they have available, because sometimes what happens is that you have some feed resources that's easily available, and then they keep animals on those, and then that feed might have good carbohydrates, but maybe deficient in protein and on fat and all that. So the animal is not really going to increase its productivity. But by actually getting a little bit of protein from somewhere else, that could really improve that. So the premise is that it's based on the local feeds that the farmers actually have available, but at the same time, it will flag what is missing. It will flag that your diet is, if you had a little bit more protein, then you could have an increase in milk production as well. So the farmers can then see if it is worthwhile to maybe buy high quality ingredients and include it, and see if it makes sense in terms of increasing production and what's the value of that milk as well. So there is a cost benefit analysis included in the tool, but is not requiring them to bring in feeds that they don't have. It's really based on what they select, they have available, and then it gives some recommendation based on that. It will add also some recommendations. If you could get X, Y, and Z, then you could increase your productivity further as well.
Great, thank you. Turning to animal health, Aimable and Seyda, perhaps for this one for you. Controlling disease, particularly transboundary diseases, requires policies and investments that are not necessarily a part of climate policy. For instance, national plans, laboratories, cold chain for vaccines, etc. How is FAO working with governments beyond NDCs?
Yeah. No, thank you for the question. I think actually the largest program of FAO, at least from our division on animal health and production, is on disease. So the largest programs on disease control that goes in epidemiology, early warning systems, in vaccinations, as well as laboratory capacities. So what is changing now is that we had a very long-term program that was highly funded by US, which was called ECTAD, so which was an emergency center for transboundary disease. Once that has been discontinued, so FAO is putting together the global partnership program, which will operate differently. So not relying on single donor, but it will be country-owned. And what we are trying to do is mainly to build partnership at country level, where private sector, government, and other stakeholders work together to address the problem. So this is very important, because what we have observed previously is that sometimes some countries may take action to address certain disease, but a few countries don't take actions, and we know that animals are moving across borders. So then that, of course, always dilute any effort of vaccination that you do. So now what we see is that there is a huge interest. So far, more than 100 countries have expressed the interest to join the program. So we look forward to see the program starting.
One of the things that also remains as a gap is alignment of the policies. So when a government publishes a policy on climate, it's important for them also to connect it to development objectives, to animal health objectives. And I think it starts with the quantification, and at the same time also improving the capacities of the governments, institutional capacities, technical capacities for the government organizations to be able to talk to each other, and to be able to leverage the opportunities and to improve the communication and collaboration.
Great. We are getting close to time. I think we can squeeze two more in perhaps. This question is, how do you account for disease in your model? Is disease specific or is it assumed? or is it assumed the negative impacts of disease overall in reproductive performance, milk, meat production, and dry matter intake?
I'll start, but Aimable had an example, so he can say more. Maybe I'll just say more from the quantification framework point of view I have just presented. So framework does not necessarily propose a modeling approach. It doesn't say you should use a model A or approach B. It is applicable to different types of methodologies. So it can be used with models, but you might also have the opportunity to measure, and if you have the measurements, you can use them to quantify. So I think that's what I can add, and then I'll pass it on to Aimable to say more about parameterization.
No, that's a good question. Of course, we shock all the parameters that could be shocked, of course, based on two things: available literature, and as well as some expert opinion, because sometimes for certain disease, those parameters are not measured, which is a challenge. So, however, we want to address that challenge. One way we are trying to do this is mainly to support animal recording at farm level. So really generating the data, understand how any disease episode would affect production, it would affect feed, and so on. This will help to better capture the role of animal health in the overall sustainability. And of course, we are also looking at long-term projections. For instance, we are working with Morocco. Morocco recently lost more than 30% of its head due to heat stress. Actually, that was the main reason. Now, what we see, for instance, we see that the country will not be able to recover the head in the next 25 years. It will be impossible, even if they take strategies to import new animals and so on. So those are the very, very big problems where actually now we are talking more about mitigation, but actually the adaptation on how we reduce the shocks. They can be animal disease, they can be climate extremes and so on the farmers, because this is really a very big trend. We see that everywhere, and most countries don't have any mechanism, insurance or the compensation schemes to help farmers recover. And sometimes when they recover, they are hit again, because some countries have experienced 7 years of drought. So meaning there is no water, so in those areas, sometimes they get abandoned.
Great, thank you. I'm going to beg the indulgence of the facilitators. We'll do a very quick lightning round, so 30 seconds each, guys. Do you have a message? What would you like to leave the audience with? What would you say to a Minister of Agriculture, maybe a Minister of Finance, maybe a development finance institution? Others in the audience, what is your sort of parting shot? What do you want us to remember? Where should we start?
Yeah, sure. I can start. I think what I'm realizing more and more is that we really need investments to make things happen. And I'm very happy to see a representative of the World Bank, who I'm sure she's taken a lot of notes. We do need that. I think without working with development banks and investment in general, I think we cannot really move the needle. And again, happy to see a lot of funders and people who are investing in this room, and that's just critical. I think without that, we're not going to go anywhere.
I would say a partnership across different organizations, research, international organizations, as to make sure that actually we bring solution on the ground. The solutions must reach the farmers.
I'll actually say finance follows quantification measurement. So we need the quantification MRV frameworks and practical policy guidance to make an impact.
Wonderful, and 30 seconds each, great. So it just remains for me to thank you all for your participation, for these great questions. Apologies, didn't get to all of them, and to thank our 3 speakers. Thank you very much.